Hi everyone, thanks for coming to my talk, and thanks to the SARS for having me here. My name is Yuki Chen, and today I'm going to introduce some bugs and tips and experience while looking for pre-auth RCE bugs in Windows components and report the bugs through the Microsoft Bounty program. Here's our agenda today. We will first have a brief introduction about the background of the research, and then we will introduce the steps and some tips if you want to try the Bounty program from as a beginner. And next, we will have some example bugs we found during our research and a conclusion at last. So why we choose to research the pre-auth RCE bugs in Windows? First of all, it is because it's a very challenging task to find such a bug which can be triggered remotely and without user interaction and authentication. And I believe by finding such bugs, report them to vendor, get them fixed, we can make our cyber world a safer place. Sorry, I lied. The true motivation of the research is the Microsoft Attack Scenario Awards that pays much higher than a normal bug. As you can see, 100K USD for a single pre-auth RCE bug. Yeah, not bad. So we love challenge, and we love big bounty even more. So let's start. So what to do if you want to try Microsoft WIP bounty program, especially for the Attack Scenario Awards as a beginner? First of all, before starting, make sure you have read the bounty rules carefully in the official program. And you have to register a MSRC research account, and keep in mind that whether your submission is in scope or not is at Microsoft's sole discretion. Yeah, literally everything can happen during the whole process, no matter how strange that sounds like. Yeah, trust me, that's gonna happen. And you have to choose a target to research, and which is the most important step, in my opinion. Make sure your target is a pre-auth and no user interaction, no authentication, and make sure the target exists in the latest Windows Insider Preview build. And you have to understand the difference between a component and a product, because usually a component is more likely to be in scope, while a product is often out of scope. Yeah, and make sure your target is not listed in the out of scope list in the bounty page. Check it carefully. Yeah. And just exploit as many features as you can to find something interesting. And once you have decided your target, just try your best to get the target crashed or get yourself crashed. Yeah. Then you have a bug, just submit it through the portal, and you will receive a bounty review email. And usually it takes 4 weeks for the review, and yeah, if you are lucky, your bug is in scope, and then congratulations, and don't forget to buy yourself a beer for your hard work. And you have to prepare for different situations, either listed here or not listed here, because everything can happen, as I said. So make sure you never ever make any assumptions about the bounty amount before the review finish. So have you ever thinking of fire your boss if you got enough money? Never do this before the bounty review finished, because yeah, if you do this and then you get an out of scope result, oh, yeah, then you know your boss will still be your boss, right? So if you are not prepared to become an independent security researcher like me, yeah, be careful and be nice to your boss. Next, let's see some example works in different targets. Yeah, the first one is the LDAP server. We choose LDAP because it's enabled by default in Windows domain controller. It has a complex function. And not many historical bugs, which means you can have a chance. And LDAP is basically a direct service based on TCP/IP stack. It's a user mode service running in LSASS, and the module name is NTDSAI. As you can see in this picture, the pre-auth attack surface of LDAP include the network transport layer, like the connect, disconnect, send, and receive things, and the parsing and the decoding of LDAP messages, and the pre-auth part of the bind request handler. So the target is very clear. We just focus on these pre-auth surfaces and see if we are lucky. The first bug example is a race condition bug, which can cause user to free. Security context can be freed by one thread while another thread is still using it. Yeah, here is a useful tip. Based on our experience, race condition bugs are very common when looking for pre-auth bugs in Windows servers. So make sure it's on your checklist. And to trigger this bug, the attacker just send a bind request to the server, which will create a security context and use it in authentication. And then, at the same time, the attacker send a stop TLS request to the server, which will free the security context, resulting user to free. This bug is interesting because basically a security context represents the authentication state of current connection. So if you can fill the freed memory with proper content, you may directly become an authenticated user, such as a domain admin. So you do not have to do traditional exploit steps like ROP or something. Yeah. And next example is also a common bug type, which is an integer overflow bug in the function LDAP request grow receive. As the name of the function indicates, this function tries to grow the receive buffer to hold more data from the client. And when calculating the size of the new buffer, it just simply multiplies the old size by 2, which causes an integer overflow, and it will be right. This bug is also an integer overflow bug. This time in message parsing, one tries to parse a distinguished name field in an LDAP request. So yeah, integer overflow bug is also something worth marking when looking for Windows Pre-auth RCE bugs. When looking for Windows RCE bugs, you may see many network protocols, including the well-known protocols and some customer protocols. And this is an example bug we find in Windows Network Load Balancing Server, which is used to balance the traffic in a cluster. NLB driver uses a customer network protocol based on multicasting. You can see the Earth type is 0x886F for the multicasting packets, and the NLB server will send something like a heartbeat packet to other servers. And any not unauthenticated user can send such a multicast message to the NLB server. And the bug is very simple. You can see it just gets an offset from the heartbeat packet and use that offset directly to write to a heap buffer without any validation. What we learned from this example is that a multicasting protocol often has a larger attack surface than normal network protocols because you have more chance to trigger it in both server and the client sides with multicasting protocol. Next, let's see some two network file system protocol bugs. The first is in the encrypted file system, which is used to encrypt and decrypt files. It is enabled by default in Windows Domain Controller, and at the time of our research, it is pre-auth, and later it is changed to require authentication because of the famous published exploit called pettipotent, which you must be familiar if you do Windows pen testing. And we try to find something from a different angle than pettipotent, so we mainly focus on memory corruption bugs and find some such bugs. This is one of them. In this bug, the attacker sends an open file request followed by a read file request to the remote EFS server. The key point here is that the file path actually points to an UNC path which is controlled by the attacker. So basically, the server just try to read the file from the attacker-controlled file share and send it back to the attacker. So the attacker can just say, like, for example, the data size is 100 bytes, and the server says, OK, I have allocated a buffer of 100 bytes. Now send me the data. And the attacker just send more than 100 bytes to the server, and the server will just copy as many bytes as received from the attacker, giving us a very nice hippo rewrite with both size and content controlled, which should be quite trivial to exploit. And next is the network file system. NFS is a major file sharing protocol, and Microsoft also has its own implementation using kernel drivers. We found some bugs in Windows NFS, and here is one example. It is a classic stack buffer overflow bug when the server tries to call back to the client and retrieve some data from the client. And as you can see, the server just copies the data from the client to a stack buffer without any checking, resulting in classic stack buffer overflow. You may notice that these two examples have a common feature, have a feature in common. In the two cases, the server and the client change their roles, which means the server becomes the client and the client becomes the server. In the first case, the server just tries to visit the remote file share prepared by the attacker, and it becomes a remote file protocol client. And in the second case, the server just callbacks to the client. It connects to the client, send a request, and receive response from the remote attacker. And as you may know, it is often easier to find a client-side bug than finding a server-side bug. So when you try to find some remote bugs in a remote server, make sure you check whether you have chance to force the server to behave as like a client and trigger some client-side bugs, because that would be easier. Last, let's see some examples in Windows remote procedure call. Windows RPC are used widely in Windows system, and the pre-auth attack surface of RPC, including the transport layer things and RPC on marshalling and marshalling. RPC on marshalling happens when the server tries to deserialize the parameters sent by the client and Marshalling happens when the server tries to send the result back to the client. And here is an example of RPC unmarshalling bug, which is a type confusion bug when the server tries to marshalling a special safe array with a particular VT type. And when we dig into RPC unmarshalling logic, we noticed a undocumented VT type 0x48. And so a remote attacker can simply trigger this bug by sending a safe array RPC parameter with this VT type, and the server just get type confusion when try to unmarshal the parameter. Next, it's an example of RPC marshalling bug. It's an integral overflow when the server tries to marshalling a big-sized BSTR string and send it back to the caller. To trigger this bug, we need to find some way to let the server send us a big BSTR string, and usually the proxy servers are somewhere to look with this requirement. Yeah. The last one, it's RPC transport bug, and if you still remember, we introduced the bug in LDAP server. And this one is almost identical to that one. It is an integral overflow bug when the server tries to grow the receive buffer to hold more data again. So you can also put this as a bug pattern in your checklist when looking for Windows pre-auth bugs. Okay, yeah, the pocket is very simple here. We just keep sending more and more data to the remote RPC peer, and the bug can get triggered. Yeah, very simple, and yeah, I just wonder why it's not reported for 20 years. Yeah, 20 years. Okay, now it is a summary for our talk today. Yeah, we introduced some bug examples and some tips, also our experiences while looking for Windows pre-auth RCE bugs. And it's not an easy task to find such a bug nowadays, but we believe that if you try harder, it's still possible. Yeah. So just keep trying, and wish everyone can get your own big bounty. Yeah, I guess that's all for our talk today. Thank you again for listening. Thank you.